Today's lesson is about how to add and subtract fractions with unlike denominators, meaning two fractions where their bottom numbers or their denominators are not the same. Let's start with a problem that you can probably figure out in your head. 1/2 minus 1/4. Now, the reason this is really just perfect for what we are talking about today is because 2 is different than 4. So your denominators, those bottom numbers in the fraction, are not alike. They are unlike. They are not the same. So let's say this box represents one whole. Make sure that you're writing this and drawing this as well. This box represents one whole. Let's make our 1/2 be represented by some pink. So remember, it's the magic whiteboard. So let's say that that is 1/2. So we're starting out with 1/2. Now we want to take away 1/4. Well, I don't have fourths to take away. I'm only working with half-size pieces. So what we need to do is we now need to pretend that we've really got fourths. So what we can do is we can pretend that we have some fourths here, and we can take one of them away. So if we take one of those fourths away, then all we're left with is 1/4. Right there. So our answer to our problem, which you've probably already figured out in your head, is 1/4. Now, in order to do this, what you were really thinking of is, how can I pretend that 1/2 is actually some amount of fourths so that I can take one of them away? And in your head, you probably knew the equivalent fraction to 1/2 was 2/4. So basically what you did was 2/4 minus 1/4. You had two of them, you took away one, and you have one left. And that's fourth grade fractions right there, adding and subtracting with fractions that have common denominators. The only difference that you did today is you turned the 1/2 into 2/4 so that you could take away the 1/4. All right, let's try another problem. Let's say that we've got a fraction, and I like to use bars for subtracting even and adding as well, but let's do another subtraction problem. Let's say that we have 9/10 represented. So if we've got this bar divided into tenths, and we have 9 of those tenths represented, that would mean that we would have 1, 2, 3, 4, 5, 6, 7, 8, and 9 of those tenths represented. And let's say in our other fraction, we have still one whole that's the same size as the 10/10 above, but this time instead of dividing it into tenths, this bar is divided into fifths. All right, and let's say that we are talking about, let's do 1, 2, 3/5 represented. So we can see, since these whole bars are the same size, and we've really done a good job of being very accurate, which I hope you have as well in your notes, we can see that we've got some areas that really match up. We can see that we've got 1/5 is the same as 2/10. And we can see that because one of them is on top of the other, so it's very, very plain to see. We've got 1/5 matches up with 2/10. Another 5th matches up with another 2/10. And our last 5th matches up with another 2/10. So If we had the subtraction problem, 9/10 minus 3/5. What we would do is we would say, well, it's as if we were taking this fifth away, this fifth away, and this fifth away, 3/5. And we are left with 1, 2, 3/10 left. 3/10 are left. So our answer would be 3/10. But we need to think about why this works, because we're not always going to draw out a picture every time that we need to solve a math problem with fractions. Basically, what we did is we thought of our 3/5 here in terms of tenths. We matched it up with our tenths. So each one of those 3/5 was actually worth 2/10. So we had 2/10, and then another 2, and another 2 for a total of 6/10. So what we really did was we changed our 3/5 into 6/10 so that we could do 9/10 minus 6/10 is 3/10. So what we've done in the past two problems is we've thought about, hey, can we rename one of these fractions to have the same denominator as one of the other ones so that way we are taking away or adding the same size pieces. But it can get trickier. Okay, so let's do a trickier one. So let's say that we had 1/4 and we wanted to add 1/6. Yikes. Well, as I look at my pie graph here, it's only divided into 4 pieces. So how am I supposed to add a 1/6 to that? The only thing I could do is right now is add another 1/4, and that would be way too much. So what I'm going to need to do is I'm going to need to rename these 4ths as if they were 6ths. But how do we do that? Well, this is why we learned about making common denominators, equivalent fractions with common denominators. Okay, so I've got my 1/4 on there, and now I'm showing how to make 6th. I've made a thirds, and if I cut each of those thirds in half, I'll have 6ths. It'll really be more about there. Okay, so now I've got some 6ths as well. So I want to take the 1/4 that I had before, and I'm adding on, there's my 1/4, and I'm wanting to add on 1/6. And basically we're saying, well, how much is that of the whole thing? We're trying to figure out what all of this is. So let's set up our addition problem. Now this should look familiar. We've got two fractions with unlike denominators. In order for us to be able to add them later on, we need to get them to be having common denominators. So we know how to do that. Let's go for it. Let's start with our 1/4 and our 1/6. Let's start by listing the multiples of 4 and listing the multiples of 6. Let's do our first 5 here. So we've got 4, 8, 12, 16. Oh, I've only got room for 4, but I think that'll be enough. And then our multiples of 6. You can say ding, ding, ding when you see one that matches. Multiples of 6, here we go. Okay, 6, 12, ha! Ding, ding, ding. 12 matches. Hooray! We have a new least common multiple, which can now be our lowest common denominator over here. Now we have to figure out what our new numerators are. We've changed the pants of the fractions, but they need a whole new outfit. Or just like brothers and sisters, you have to treat them evenly or fairly, or they will be upset and it won't be good for anyone. So now that we've changed the denominators, we also have to change the numerators. So what we need to do right now is kind of like an algebra problem, figure out how we got our new denominators. So let's start with our 4. To get from 4 to 12, what did we do? 4 times what is 12? Times 3. And whatever we do to the denominator, we have to do to the numerator. So we'll multiply the numerator times 3 as well. So now we have 3/12, and I'm going to box that up because I want to remember it and come back to it later. Now let's do the same thing for the 1/6. To get from 6 to 12, what did we do? 6 times what is 12? 6 times 2 is 12. And whatever we do to the denominator, you have to do to the numerator. So we will also multiply our numerator times 2. And 1 times 2 is 2. So we've got 2/12. Now we have an addition problem that we can actually do. Just like when we used common denominators to compare fractions and see which one was greater and which one was less, now we can use our common denominators to add and subtract them since we're talking about the same size pieces. So now we have 3/12 plus 2/12 would be how many 12ths? That would be 5/12. Final answer. Remember that when we're adding and subtracting, we only add and subtract the numerators. The denominator is just telling us what size pieces we have, not how many. The numerator tells us how many we have, and the piece size is not changing. So let's list our steps that we've been doing so far, because this is a lot to keep track of. So let's list our steps. First, and write this down in your how-to books. First, list the multiples of my denominators and find the least common multiple. Second, set up equivalent fractions using my least common multiple as my new denominators, or my new least common denominators, or lowest common denominators. Third, find my new numerators by multiplying the same way as my denominators. So that's when I always say, and how did I get to my new denominator? If it was multiplying by 2, then whatever I do to my denominator, I have to do to my numerator, and I would multiply by 2 for the numerator as well. And last but not least, don't forget the whole point of the problem, to add or subtract. You wouldn't believe how many 5th graders I get that go through all the trouble of finding the multiples and finding the least common multiple and making the new equivalent fractions, and then they say, cool, I'm done. Well, no, you're not. You still need to do the problem, which is either adding or subtracting. And you wouldn't believe how many 5th graders I get that do the wrong operation. For some reason, they add instead of subtracting, or they subtract instead of adding. So you need to make sure that you look at the operation sign, whether it's an addition sign or a subtraction sign, really carefully before you just ruin the entire problem that you spent so long working on. It's always a bummer when that happens, but I can lighten the mood by singing to you. I saw the sign, and it opened up my eyes, I saw the sign. Yeah, you really don't want me to have to sing that to you, though, because that would mean that you made a silly mistake and that you should have looked more carefully. So those are the 4 steps that we are working with today for adding and subtracting fractions with unlike denominators. Your task tonight is going to be something really, really different than anything that you've probably done before. What I want you to do is come up with your own either adding or subtracting problem that you come up with and write it as a word problem, like Mia had 3/4 of an apple and she gave 2/8 to Caitlin. How much does she have left? So some sort of a word problem where you are either adding or subtracting fractions, but you all have to come up with the same answer. Your answer has to be, in the end, 13/20. Okay, your rules. Write it as a story problem. You may add or subtract. You need to start with two fractions that have unlike denominators. You cannot use 20ths as one of your original denominators for the two fractions you start with. So think about some fractions that you might change into 20ths, where your two denominators would share the multiple of 20. And, of course, show all of your work and solve the problem to prove that 13/20 is, in fact, your final answer.